Hey guys, today we're going to take a look at the domain and range of functions. So, there's many different ways to determine domain and range, but we're going to look at a couple different scenarios. So first of all, it is worth mentioning, so domain and range, remember, this is a list of all the possible inputs and outputs that you can have for any function. It's all the domain's all the inputs you can have, the range is all the outputs you can have. And sometimes we forget that if we have an equation representing something that's real world, that's the key here. If it's real world, okay, then that can sometimes restrict things. So for instance, if I have a distance versus time graph, I can't have negative time or negative distance. These things don't exist, right? There's no such thing. So that's something to keep in mind when you're doing domain and range if it's a word problem in particular, okay? So if the equation is in the form right here, so this is our vertex form of a quadratic. So hopefully you remember from last year that the vertex of this parabola is just going to be the point h and k, whatever the h and k are. So your x value for your vertex is the h, which you'll find right there. And then your k value, or sorry, your y value is k, which you'll find as whatever is right there at the end. Okay? The a value here, I can make a note of that too. So we get the a value, which we find right here. That's going to help us determine the direction of opening. Remember, if your a value is positive, then your parabola is going to open up. If your a value is negative, it's going to open down. Okay? So these are the things that we need to know in order to find the domain and range of quadratics in particular, okay? Which is one of the things we're going to be focusing on. So first of all, one of the easy things, or I should say easiest ways to sort of determine it is there's a lot of similarities, particularly if we're dealing with linear functions or quadratic functions, okay? So if we're dealing with a linear function, so if it's an equation of a line, right off the bat, we know that the domain, which we'll do right here, is just going to be everything, right? There's no x value you can't put in to any line, with a couple exceptions, which we'll talk about in a second. But so this is how you're going to write it here. You're going to write it as x, and then we've got this e-looking thing, and what this means is an element of, and then we do a capital R. Sometimes we'll write it like this. We'll do like a thing like that. Sometimes it doesn't type like that, but that's usually how we do it when we write it by hand. So that just means the set of all real numbers, and that just means all possible numbers that are just, anything, right? It can be an integer, it can be a fraction, it can be decimal, it doesn't matter. Any number, x can be any number. And the range is going to be exactly the same thing. It's going to be that y is an element of the real numbers. Okay, y can be anything for any line. And there are two exceptions, of course. We've got vertical lines and we've got horizontal lines. Okay? And that makes sense because if I draw a quick sketch here of a horizontal line, which goes like that, well, there's only one y value that's allowed. That's the only y value you're allowed. Now, the domain for that can be anything. It can go back and forth forever. So in that case, for a horizontal line, the domain is going to be any real numbers, but your range is just going to be that one single number. And then if it's a vertical line, it's the exact same, only backwards. The range can be anything. It can go up forever, and it can go down forever. So the range can be anything, but the domain is then limited to just that one single number. And of course, you can remember that you have a horizontal line because it will be y equals, and it'll just be a number. Okay, that's going to give you a horizontal line. And if you have a vertical line, it will be x equals a number. Okay? All right, a quadratic function, for any quadratic, your domain is always going to be anything. So it's, again, x is an element of the real numbers for the domain of a quadratic function. There's no exceptions to that this time. Okay? Your range is going to be slightly more difficult. We're going to talk about that in a second. But you're going to want to use the vertex and the direction of opening to be able to figure it out. That's all you need. Those are the two things you need. You need the y value of the vertex, which is also the max or min value, and you need to know whether it opens up or down. Okay? So first of all, Yeah, so otherwise, the other thing that we can do is we can graph using technology, which you can, if you're doing homework or something and you want to quickly graph it, the best way to do it is to just go to Desmos, which is a website. You can just type in any equation and it will graph it for you. So that's a great way to do it, okay? So let's just take a look here at some examples. So our first one, here. So you want to look at the form, our form here is just y equals mx plus b, okay? And so this means that this is a line. Now we know it's not a horizontal line because then it would be y equals a constant. We know it's not a vertical line because then it would be x equals a constant. So we know it's a line and we can see it's got a slope and a y-intercept, but that's not really matters. Well, all that matters is it's a line, which means that our domain is going to be x is an element of the real numbers. And our range is going to be y is an element of the real numbers. And that's all there is to it. So once you've determined that it's a line, that's all you need. Okay. Over here, we can jump here, and we've got ourselves quadratic. Okay. So first of all, a couple things to note. So first of all, we need to look here at this a value, and that tells us that it opens down. Opens down. Okay, and we know that because it's negative. Okay, the fact that it's a negative number, the 2 doesn't even matter. All that matters is it's a negative. That tells us that it opens down. Okay, now the other thing that matters is the vertex. Now the vertex is 4, 1. The 4 doesn't even actually matter. All that matters here is just this 1, the number at the end there. And that tells us that it's got a maximum value. It could have been a minimum, but it opens down. So if it opens down, it looks like this, which means that it has a maximum point. This point right here is the maximum point, and the y value of that is just going to be the number 1. So it's got a maximum of 1, it opens down, and that's enough to tell us everything we need to know. So again, the domain for a parabola is just going to be x as an element of the real numbers. But now we can do the range, which is more complicated. Okay, and the way we're going to write this is going to be a little tricky, but it just looks hard. It doesn't actually, it's just the same letters every time. So what you're going to do is you're going to say it's y such that, that's what that line is, it's just a vertical line, such that y is less than or equal to the number 1, which was our maximum value. And of course, if that was a minimum value, we do greater than or equal to. And then we do where y is an element of the real numbers. And that's it. So again, this part here and this part here are always going to be there. So you can just copy those out. You don't even have to really be thinking when you do those. You know those are going to be there. The only tricky part is coming up with this part here. And again, that just goes back to this maximum value, okay? So you needed to know that it was at 1, and you needed to know that it opened down, so we knew that it was a maximum value, not a minimum value. And that's all you need to know, okay? So this next one here, we are going to talk, I'm actually going to complete the square here, just for fun, because, you know, we'll hopefully, or maybe you remember this from last year. And maybe you don't, and that's okay. There's nothing wrong with that. That's okay. We're just going to factor that out there, plus 200. But the real way to do this, or what I would expect you to do for something like this, if you got it in the homework or something, I wouldn't give this one on a test yet because we haven't really talked about completing the square. But what you would do is you would just go to Desmos, you go to Desmos and you just have it graph it for you. You just type it in exactly how you see it, and yeah, and then it'll just do it for you to graph it, and you'll be able to just look at it and see. Okay, but I like to complete the square sometimes because that's who I am. I'm just the coolest man in the world. So let's see. So we have minus 50 plus 200. And so there we go. So all I've done here by completing the square, which is something that you hopefully remember from last year, and if you don't, not a big deal at all. But all it would do is convert it to vertex form. So now I can say, well, my max or min point is 150. And because this is a positive number, it opens up. So it's going to have this shape to it, which means it's going to have a minimum value. Okay, if it opens up, it's going to have a minimum value. So now I can go to do my domain, which I could have done my domain right from the start, because it's just x is an element of the real numbers. And then I'll do my range, which is going to be y, such that y is now, and because it opens up, it's a minimum value, so y is greater than or equal to the 150. And that's where y is an element of the real numbers. And that's it. Okay? So there you go. So let's jump over here. Let's take a look at some other ones. Okay, so we're going to do another one. This is where we look at the graph of the function. Okay, so we're going to look at the graph and come up with it. So first of all, if the graph is a line, be careful that it's not horizontal or vertical, because of course those were our two exceptions to if it's linear. If it's a parabola, we're going to locate the vertex and the direction of opening to determine the domain and range. Now there is a little bit of a trick here, because sometimes it's going to be restricted. So I'm actually going to do example B first, just because I want to, because it's easier. Okay, so we look at B, and B is, it's just a line, okay? And what's important, you see these arrows on the end? That means that this line is going forever in both directions, okay? So as a result of that, I can have any x value. It's just going to keep going and going. It's going to keep going and going that way too. So our domain is just x is an element of the real numbers. Okay. Similarly, I've got a y value. It just goes on in either direction as well. I can just go as far as I want, and it's still going to have something. So there's my y value. There's my range there. Now this next one here, this is a little tricky. Okay, because it looks obvious. It's the same. It's clearly a parabola, but you can see this one. It doesn't have any arrows on the end. Okay, and what that means is this one's obviously based on an application problem. And what that means is that it can't go on and on forever. It's sort of a what you see is what you get situation. So our domain isn't going anywhere past 7. And it's not going to go anywhere past 0 either. Okay, so what we're going to do is we're going to write x such that x is greater or equal to 0, but then it's also less than or equal to 7, where x is an element of the real numbers. And that's it. Okay? So now we look at our range. So now we're looking at the y's. And again, so we look here, and it doesn't go anywhere below 0, and it doesn't go anywhere above 50. So we're going to do the same thing. We're going to say y such that y is greater or equal than 0 and greater or equal than, I've already forgotten what number I said. 50, it was 50. 50. And that's y is an element of the real numbers. And that's it. So there you go. It's one of these things that when you're all done, when you look at these answers here, they look pretty intimidating, but they're really not actually that difficult. You just sort of have to say, what does the value have to be between? Okay? All right. So there you go. Tomorrow class, this is not homework. This is going to be classwork. We'll be working on these pages here. And there you go. So until next time, go Sabres.